Hello, everyone. This is 𝗂𝗵𝘁'𝘀 from PrimeVault. Um, we on our first of the PrimeVault architecture series. Um, in this module, we'll be talking about the main problems that crypto users face. Um, and the whole idea of this whole series is to go into some of the details about how and why PrimeVault works the way that it does. We'll start off talking about what we call the vault problem. At a high level, it seems like crypto is very simple for users to deal with because you have your own ownership of your keys. If you have a wallet, all you need to do is have the keys for that, and then you'll be able to do whatever you want, and you can manage your keys however you'd like. This flexibility is very convenient in crypto, but one of the unfortunate problems with it is that the flexibility is something that actually not a lot of organizations really want. Essentially, the problem is that like at an architectural level, crypto is really designed for individuals who have individual authority over their own funds, and it's not really designed for groups who are trying to coordinate with one another. For example, um, imagine that if you had like a traditional situation where you've got a company credit card. Okay, so there's a company credit card, and it's reasonable to take that credit card and just like hand it to your intern when they go down to a restaurant to, like get lunch for the team. Now, there's not really a risk of the intern using the credit card, um, making it so that they can permanently access like all of your funds. Even if they like memorize the codes on the credit card, you're not really worried about them doing anything wrong because we know that we could just talk to the bank and they'll listen to us and they could turn off that credit card, we could dispute transactions and so on. Um, but all of those things are not really possible with cryptographic keys. If your intern memorizes the numbers, there's really nothing that you can do about it other than move the funds to another place, which is not exactly the same thing as canceling a credit card. Essentially, one of the main problems is that modern crypto, there's this large and complicated and hard to define policy about when you're allowed to use a key and what you're allowed to use it for, that organizations have very particular opinions about what they want to happen. And there's really nothing in crypto that makes it so that this is easy to do. It's not like built in any way. And that's something that needs to be added. Now, most people, when they think about this problem, they will imagine that what they need to do is just like add a smart contract. Because people in crypto, they have this intuition that all problems can be solved by a smart contract. So what they do is they say, okay, well, rather than having an individual key for our company, we're going to have a smart contract, and that smart contract is going to manage the funds for, the whole organization. And then there would be like a different set of keys that would go to each user, and they would use their particular key to communicate with the smart contract. And now each user would have individual authority over their own like smart contract interface key, but the funds, they would be inside of the smart contract. And the intuition, this like idea is basically what's behind what are called smart vaults, which are basically, smart contracts that manage funds for groups. You can kind of think of DAOs as being like a particular, use case of these that has some kind of like open-ended rules associated with it. But now there's sort of some main, like really straightforward problems with this strategy. One of the first problems is, of course, that like the policy and all its interactions are necessarily public because all interactions with the smart contract are public. And then another problem is that all of the actions that the vault takes are going to be things that can occur on chain, meaning that it's not really possible to do like off-chain transactions, like, interacting with centralized exchanges or interacting with like other chains. Any time that you tried to do that, you would basically be forced to turn that into an on-chain interaction by using some, pre-existing bridging mechanism. Now, all of these difficulties and all the capabilities that you might want a policy to have, one of the biggest problems is, of course, that you have to think of all of those things beforehand because the smart contract is going to be immutable. And if it weren't immutable, then that's kind of its own security problem because now you have to worry about who can change the smart contract and when they can do it and how you're going to authorize that. So basically, people find themselves when they try to use smart vaults in this situation where there's this huge number of different kinds of transactions that they want to be involved in. There's the on-chain ones, the off-chain ones, the cross-chain ones, and then there's also like what you might call administrative transactions, meaning like ones that are about the vault. So, for example, like once you have a vault, you start thinking about how to interact with the vault itself, i.e., like adding new users and giving them permission and modifying the rules, as opposed to interacting with the things that the vault protects. And most people, when they think about the smart contract or smart vault problem, they're focused entirely on the keys and they basically ignore the administrative transactions and they ignore the complexity of the policy for how to do that interaction. And so all of these different interactions that you want to have with your vault, the on-chain, off-chain, cross-chain, administrative, like all of those have to be mitigated by some policy. And our perspective at PrimeVault is that like this policy is the complicated thing. Yes, it's very interesting to come up with new cryptographic ways of sealing keys, but in some ways, that's sort of like the easy problem to solve. And it's not that it's easy, like the work of cryptographers who discover these algorithms is amazing and very useful. The thing though is that they are sort of working in a really easy scenario where the problem space is like really well defined. And because it's well defined, they can come up with a solution that's like definitely right. But at PrimeVault, we think that the biggest difficulty and the main interesting thing is building the custodial or non-custodial vault, or really any vault for secured keys that has a flexible, powerful, and trustworthy policy layer. And we think that the crucial ingredient to doing this right is to try to understand how to manage those interactions and try to understand what you want the policy to do. And that is the expertise, or at least one of the main expertises that PrimeVault brings to the table. Because dealing with cryptographic keys is not simply a matter of cryptography, and it's not simply a matter of just doing what everyone else does. And this is what makes PrimeVault special. This is where we focus on. And we think that not only can we do we do this in a way that's even better than other people in terms of what your policy can say, but we also think that there are lots of risks and challenges about doing it right that other people are ignoring. For example, how can you make sure that you express what you really want in your policy and ensure that what you want is actually enforced by the policy in the vault? There's sort of this like abstraction problem. Do you know what you want? Can you say it? And do you have confidence that the policy enforcement mechanism is actually going to do that and nothing else? And of course, we have to do this in a way that's flexible to handle new situations, but not so flexible that you can't constrain the activity that happens to your vault in a way that's safe. Now, this is just like an introduction to the main problems that Prime Vault is focused on. Um, and we'll talk more about those details, as we get deeper into the architecture of these series. Thank you very much for listening today, and I'll talk to you next time.